I study things you can't normally see with your own eyes. The ultraviolet, the infrared. We can even build cameras that see very low levels of light. Quantum photonics is studying light at its fundamental level. So one thing we can do is see light moving, and for that we need a very fast camera called a single pixel camera. So it can work in the ultraviolet or the infrared. And at that point we're taking pictures at 100 billion times a second. Imagine you're driving along the road and there's something at the side that jumps out into the road. What if your car could see that before you could, and your car would be able to avoid that impact? Now, all images contain information, they contain data. So we are trying to transmit images that no one else can see. We've called this the invisible bat signal. So one thing I really like about optics is that you're building things. You're having to make the experiments to actually see things. So every day I'm working with lasers, with lenses, with detectors. And so I've spent most of my working life working with lasers in one way or another. So the University of Glasgow is fantastic because it's got so much history. And certainly as a physicist, it was the home of Lord Kelvin, who's a major part of the history of physics. The ARC has brought together so many researchers from diverse areas of the university. But I've also been involved with things with outreach, with psychologists and artists. Optics and imaging is very practical. Humans experience the world through their eyes. They take in so much information. And so it's really interesting to think about all the things that we can't currently see and maybe we'll be able to see in the future. I'm Dr. Stephen Johnson. I work in quantum and nanotechnology at the University of Glasgow.